Good evening. In this class, we're gonna continue covering chapter 8 topics. Last time we did cover the TCNT free running counter and how to do periodic interrupts through the TCNT. So another way other than the real-time interrupts we covered in the interrupts chapter. We gave an idea about input capture and out compare. I also talked about lab 6. Today we're gonna see how we can set up the input capture and out compare and generate interrupts out of them, and see applications that we can use them through. I'm gonna skip, I wasn't planning, but I'm gonna skim really quick through pulse accumulators and the countdown timers. The concept is gonna be the same as what we covered in the past. And maybe PWM, maybe we're not gonna do it today. If we don't have time, we'll do it next time, no problem. So here is where we stopped last time. Input capture functions. And we said in the last class meeting that input capture in general means whenever a rising edge or a falling edge or both, something that we can configure, okay, arrives on a pin associated with the input capture channel. And we said we had 8 channels that we can configure as input capture or output compare, either. Okay, whenever a rising edge comes, there is a logic, there are circuitry that will go latch the value in the TCNT counter and store it in a capture register. I think it's called the capture register TC0 in timer capture register. Capture or compare. If we configure the pin as capture, then it's going to be, see, we said last time that each of these channels, you can configure it as input capture or output compare. Each one of these has a data register called TC0 for here, TC1 for here, TC2 for here, and so on, TC7 for channel 7. Anytime a rising edge that arrives, you configure this as an input capture. Anytime a rising edge comes, the value in this TCNT counter will be copied to the register associated with this one that is called the capture or compare register, TC3 in this case. The value in here will be copied. Of course, this is being triggered through a clock, okay, in a frequency that we did set up as we saw last time. Same for other. You may configure this as input capture to be triggered on a falling edge. It will, whenever a falling edge arrives here, the value of the TCNT counter will be copied to timer capture compare channel, in this case 4. Why is this important? We can configure our input capture channel to capture the value of the TCNT timer or counter on a rising edge. Whenever this happens, we can go immediately configure it to latch it again on a falling edge. In this case, you will have a timer value over here that was, for example, 0x 0. Okay, that was 0x0001, and then you captured it here, and the value was 0x0006. The difference is 5, and if this was counting one count every 1 microsecond, then the time between the rising edge and the falling edge is 5 microseconds. So you can use it to measure times. And also we can configure this whenever an event happens, a rising edge happens or a falling edge happens here, this can trigger an interrupt on the associated channel, and every one of these has an interrupt address interrupt service routine that you can write, and the addresses of these interrupts can be found in the interrupt vector that we had. We're going to use it when we write code. Where was it? It was, let me copy or open it in the CPU datasheet. When we talk about interrupts, and it was in the datasheet, where was it? Exceptions. Yeah. And the interrupts vector address. Okay, or Control F vector. Okay. It should be I can find it. Maybe the other datasheet is easier. The controller datasheet. The controller datasheet. It is in our slides, anyways, Wassani. It was part of the CRG block, right? Well, interrupts, reset, initialize, interrupt operation. This is the interrupt operation, but there is an interrupt vector table that has all the interrupts. Okay. I don't know what's going on. I'm not feeling well, by the way. So it was here in chapter 6. I copied it to the slides. It is here. Okay, so it is here. Here are the interrupts. So this is the real-time interrupt we covered in the past, and from here to here to 15, from interrupt 8 to interrupt 15 can be configured to happen on an input capture event or output compare event. The timer overflow interrupt that we covered last time was timer 16. We have pulse accumulators we're going to cover later or talk about later. These are 17 and 18. And the modulus countdown timer has an interrupt when it underflows. Okay, so in the table you can find the addresses of all interrupts. Okay, let's keep this open here. طيب, so we can configure an interrupt. مصطفى تفضل.
هلا هون حكيت انت بالفولينج ايدج او الرايسنج ايدج. يعني انا من البدايه بتعرف انه بيشتغل على الفولينج ايدج او الرايسنج ايدج.
Yes.
يعني مش على التنتين سوا انه and.
We can do both or only rising or only falling or both. Yeah, we're going to see.
تمام.
It is something we program or configure. طيب. So we were here. So on a rising edge or falling or both, we can latch the value in the TCNT in the timer capture compare register, 16-bit to be able to take the 16-bit in the TCNT. Okay, how do we configure the bits or the channels to work in the input capture mode or output compare mode? These channels. How do we make this input capture method? Let's say we want to configure the first 4 as input capture and the last 4 as output compare How do we do this? We do it through programming the TIOS register, the timer input capture output compare register. A 0 means input capture, a 1 means output compare. So to do the input capture for the first 4 channels, we write zeros here. To do output compare in the last 4 channels, we write ones here. Oops. Right. ماشي, we write y ones here. Okay, so this is the first thing we do. We configure that the channel is going to work in the input mode or the output mode, input capture or output compare. These pins, the pins that we're talking about, these pins are also shared with port T, port T0, port T1, port T2, and so on. So port T is a parallel port that you can use as just like when we were using port B method or port H or whatever. Okay. If we do not enable the timer function, how did we enable the timer function? Last time, if you remember, if we did not enable the TCNT, all input capture and output compare are based on the TCNT. If it's not enabled, then no input capture, no output compare. So this is the bit that will enable the timer functions. Okay. If this is 0, then port T is going to be normal parallel port. If this becomes a 1, then port T pins are going to be input capture or output compare pins. The default, if you don't program them, are all zeros. They're all input capture. You can change any of them to be output compare. Okay, so the timer port pins can work as parallel ports shared with port T. Okay, and in this case, the direction of port T to be output or input is controlled by the data direction register of port T, DDRT. Okay. Okay. This is what we just talked about. Okay. Now, when we are in the capture mode, yeah, Mustafa, this is your question. Do we want to capture on a rising edge? We want to capture on the falling edge or on both? So for channel 0, مثلا, we want to make it capture on, if it's disabled, the pin will be port, digital port. If it is enabled, you have to select one of these. If you write 0, 1 in it, then you're capturing the value of the TCNT counter on a rising edge. If you write a 1, 0, you're capturing the TCNT counter value on a falling edge. If you write a 1, 1, then on either rising or falling. You're going to capture on both edges. Okay. The other 2 bits are for channel 1. The other 2 bits are for channel 2. And so on. So because each channel has 2 bits to be configured, and we have 8 channels, so we need 16-bit 2 registers, TCL, TL4 and 3. Okay. Whenever this happens, the rising or falling or both edges happen according to your configuration, the value of the TCNT counter will be latched to the timer channel capture or compare register that is also 16-bit. And we said last time, if you forgot, that the TCNT counter or timer is running in the background. You don't care about making sure that it is running in your software. The hardware is doing that for you. You only can configure the speed of how fast it's counting, and you can read it at any point of time or write it at any point of time. Okay, so this is input capture. Now, when any of these happen, a rising edge, a falling edge, or both, yani a capture happens. When a capture happens, yani the TCNT counter is copied, latched to the respective register, data register. You can configure a timer, an interrupt to interrupt your normal program execution. We have 8 channels, so we have 8 interrupts. These are enabled or disabled through 8 bits in a register called TIE register, timer interrupt enable register. So if you write a 1 here, This means if a falling edge is going to arrive on input capture or output compare, if you did it channel 0, okay, this will cause an interrupt. And this will send the program counter to the code you wrote in interrupt service routine for input capture channel 0. Okay, same for the other ones. If you configured it as an output compare channel, again, when a compare happens, a successful compare happens, the interrupt is gonna happen and interrupt the interrupt service routine. And again, so these are the local enables for the 8 interrupts. And any interrupt, when it happens, a flag has to raise. And these 8 flags for these 8 interrupts are stored in a register called T flag 1. 8 bits, 8 flags for the 8 interrupts. And these flags are flags that you need to clear inside your interrupt service routine, so not to get stuck in the interrupt service routine. Okay, I assume the process of interrupts and how we write interrupt service routine and program them is clear now. We have a global interrupt enabled. The local interrupt enables are here. When a capture happens, a flag will raise. Okay, if the interrupt is enabled, your program counter is going to be sent to the interrupt service routine. Okay, how do we clear a flag? We write a 1 to it in this register. Okay, how do we clear a flag? We write a 1 to it. ماشي. طيب, some applications on input capture functions. Input capture, you can go configure your input capture. And again, if you want to look at it this way, these, if you enable the interrupts on input capture here, it would look like as if you have 8 external interrupt sources, صح؟ we had an external interrupt اللي هو IRQ, صح؟ We had, this is a clear and 4 external interrupts, IRQ, and we did the lab on it, right? And we did the class demo on it. But if we enable interrupts on the capture compare channels and configure these channels as input channels, then you will be able to detect any rising edge or falling edge or both, and this would cause you an interrupt. So it is just like having 8 IRQs extra.
دكتور لو سمحت سؤال.
Yes, a second, Yazid. You will have 8 interrupts. In addition to these, you will have a timer value that will be lashed into a timer channel register, right? You may ignore it, maybe you don't want it, but you will still get the interrupt. Go ahead, Yazid.
دكتور احنا اخذنا اكثر من نوع انتربت يعني هل يعني ملزم انا مثلا بانتربت معين ولا انه مثلا خلص الابلكيشن هو اللي بيحدد لي مثلا شو اللي بدي استخدمه انا او
Well, it's your design that decides. Your design. The design, of course, is tied to the application. You decide. Yeah, in a setting, sometimes, if you're part of a team designing a big system, maybe the design requirements will require you as an engineer working on a subsystem. You don't have the big picture. Maybe you will be asked, the owner of the application or of the system, you said, can give you some constraints or design requirements that you are only allowed to detect rising edges or falling edges on pin port T5 or port T6. In this case, you're forced to use them, right? If you're not, you can go use the IRQ pin, right? Or the XIRQ pin. It depends. In general, it's up to you unless you are asked by the owner or you have some design requirements you have to meet. But now we did program real-time interrupts. We did program IRQ interrupts. I'm going to share or do with you input capture interrupts, output compare interrupts. So the concept is the same. You enable the interrupts locally in their local enable, globally, write an interrupt service routine, use the address available in the interrupt vector, write what you want to do when this happens, then clear the flag before you return. This just was an idea on the side that it's just like you're having more extra 8 IRQ interrupts. Some applications that you want to use the input capture functionality for is to capture time or value of a running timer on a rising edge between always on rising edges. In this case, if you have a square wave coming on a rising edge, you'll have the value. On another rising edge, you have the value. You can go subtract the TC and T timer value when it is captured here to, if we are at channel 0 to TC0, then store it at somewhere called edge 1, right? When an interrupt happens, or you keep waiting for the flag to raise and go capture it. And when it happens again, go save it at edge 2. Then you have two values, subtract them. The difference will be how many times you counted here. If you counted 10 times and each count takes 1 millisecond, then this period is 10 milliseconds. Okay. If the period is 100 milliseconds, fine. If you're incrementing every 1 millisecond, you can measure periods up to 65,536 milliseconds. If you don't know the period here, maybe 200, 300, 5,000, 5 seconds, 2 seconds, you don't know. In this case, you will have to capture the value, then keep track of how many times your TCNT timer overflowed. So you need to enable the TCNT overflow interrupt, count how many times it overflowed. Between every overflow, so you capture the TCNT timer here, then it overflow here, overflow here, overflow here, then you capture it again. This means if you captured it when it was here, the value of the TCNT timer was 100, that's in decimal, and when you captured it here, the value was 50, and it overflew here, then over here, then here. Between the overflow and the overflow is how many times? 65,536 counts. Oh, command high, 65,536 counts. And here you have 100 counts. And here you have 65,536 counts minus how many? Minus 50. So you have a number here. Add this plus this plus this plus the result of the subtraction here. You will have the how many times, how many counts you had. And every time you had 1 millisecond times 1 millisecond, this is your pulse width, or the period. So my point here, if you don't know the period that is coming, and it's not guaranteed that it is less than one before an overflow will happen, you will need to keep track of how many times the TCNT timer will overflow. Again, same concept. You can measure it between rising edges, still measure periods. You can measure between a rising edge. Then when the rising edge happens inside your interrupt service routine, go change it to become next time to happen on a falling edge. In this case, you can capture it on a rising edge, then on a falling edge. In this case, you measure the pulse width, just like here. And again, it's not necessary that these events, rising edges, are just square waves coming from a function generator. These can be coming from on a pin, from a push button or a button tied to your door, or coming from a sensor like a sonar sensor that you need to know the time between a rising edge or an event that happens and another event. Anyways, so a rising edge, you can generate it as any application you want using any way. Okay. And this is something that I just mentioned, that all the input capture functions can be programmed as interrupt sources. So a rising edge came, it will latch, capture the value of the TCNT timer, use it, store it in the capture register, and generate you an interrupt. So as if you have 8 extra interrupt sources. You can use it also for event counting. Every time a rising edge cap happens, this is an event. You don't care about the time between events, but every time a rising edge happens, an interrupt will happen, it will add a counter. So you will count how many rising edges you receive. So event, counting events, another application. Timing between the events. In this case, you will take the value of the TCNT, okay? And then when it happens again, this is your reference, and measure this time. Okay. And if you were able to capture on rising, falling, rising, and tell it to capture on every rising or falling edge, you will be able to, the first two captures will be the pulse with the third capture, and the first one will be the period, and you will be able to compute your duty cycle. Phase shifts, maybe. Many applications, okay? To measure a period, and this is a good example. مثلا, you're asked to measure a period for a pulse coming on input capture 0. Here you are required using input capture 0 to measure the period of unknown signal. You don't know how the signal looks like. You want to capture the period. The period means between two rising edges. So the period is known to be shorter than 128 milliseconds. This is the only given thing to you. And your E clock frequency is 24 megahertz. 24 megahertz. How would you measure the period? We have two options. Either if this is if the TCNT is running using the E clock as is without a prescaler, then you're running really fast. Huh? So how much time will it take before an overflow happens? 1 divided by 24 million, right? Oops, sorry. 1 divided by 24 megahertz. And this is how much? 416 microseconds. Huh? نانوسكند. In microseconds بيطلع 0.04 microseconds. Huh? 0.04 microseconds times 65,536 when an interrupt happens, or 65,536 an overflow happens, then you're gonna overflow 1, 2, 3 after 2.7 milliseconds. 2.7 milliseconds, and you know that you are at 128 milliseconds. They had it here, 2.7 milliseconds. You will overflow after 2.7 milliseconds. So you cannot use the E clock as is to run the TCNT and just like that. Either you have option 1, you can keep it running this fast and flip over every 2.73 milliseconds using the 1 prescaler, but you will have to keep track of how many times the counter overflows. You need to enable the overflow time or overflow function. Every time the overflow happens, you go increment I method or a counter. And every time I is incremented, this means that you have gone through 65,536 counts. You add them. Okay? Or you have another option. Go ahead.
هذا هو البيريود 2.73 ملي سكند.
هاي 2.7 مصطفى احنا if our TCNT counter is running with the speed of the E clock, the E clock is at here 24 megahertz. 24 megahertz. So the time, هاي E clock. On every rising edge, the time between a rising edge and every rising edge, a count will happen for the TCNT. So it will increment. This time is 1 over 24 megahertz. طيب, the TCNT timer is 16 bits, so it will count 2 to the 16, 65,536 times this, and this will be 2.73 milliseconds. Until what? until this TCNT timer counts from 0 down to 65,536 اللي F 4 Fs and goes back to 0 اللي the time to overflow. Okay. This is the 2.7. If you use the E-clock as is, you did not prescale it. تمام؟
تمام.
طيب, if I have this fact, this is my TCNT counter that is running this fast. How am I going to measure a period of 128 milliseconds? This is not enough. We know we're going to flip before 128. In this case, you need to go enable the timer overflow interrupt. We saw last time. You enable it inside the interrupt service routine. Every time you get there in the interrupt service routine, timer overflow, you increment a counter, مثلا I++, and you use it in your math. This is one option. The other option is to slow down your E-clock through a prescaler. We saw last time that the TCNT timer can be prescaled through any of these prescalers. Slow it 2 times, 4 times, 8, 16, 30, up to 128. For example, in this case, in this example, he's assuming that you can set the prescaler at 64. This means the overflow will not happen every 2.73 milliseconds. Will happen how much? Times 64. بتصير كم؟ بتصير 2.73 milliseconds times 64. It will happen every 174 milliseconds. 174 milliseconds is larger than 128, then you're good. So then you're good. You will not have to keep track of how many overflows happen, because it's not going to overflow. It's not going to overflow before 174 milliseconds. And you know that your signal is going to come and end somewhere here, right? Before finishing. This is another way.
دكتور سؤال صغير ممكن؟
مصطفى تفضل.
هلا هون بحكي انا عن اما رايسنج ايدج او فولينج ايدج، يعني 1 ايدج افري بيريود، صح؟
البيريود of a signal coming in on a channel is this, right? Is between 2 rising edges or 2 falling edges. This is the period.
اوكي، بس هو بالاكزامبل عن 1 ايدج افري بيريود، مش عن انه باخذ على الرايس والفولينج ايدج. لو بدي الرايس والفولينج باخذ البلس ويدث، انا هون نص البيريود.
Yes. So you will need to take 2 rises or 2 fallings to get to measure the period. Yes. مش on a rising and the other time on the falling. Either all rising or all falling. Yes. And this is a flow chart of some code you can do. So this is a flow chart, and this is code to do this using the pulling method, monitoring the flag. And I'm going to share with you some demo using the interrupts. Okay. So to do it, choose the to capture the rising edge. On the rising edge, we know the register to do that. Use the prescaler for the TCNT counter as 16 مثلا. Enable the timer counter. It will start counting. Okay. It will start. Clear the channel flag, channel 0 flag, and keep waiting it to be 1, to become a 1. While this is 0, stay stuck here. When it becomes a 1, go save the capture register. The capture register, the TC0. Save it somewhere called edge 1. Okay, and clear the flag. Then wait for it again. It's going to happen again. The flag is going to raise again on the second rising edge. So keep waiting while the flag is 0. Stay stuck here. When it's 1, you go here and go copy the timer channel 0 register. You store it in edge 2, right? Now the time you know that you clear the TCNT here. You cleared it. Okay. Or when this happens, you can clear the flag. So the difference between edge 2 and edge 1, edge 2 minus edge 1 will be the number of counts between the will be the number of counts between the two rising edges, right? Subtract them, and you know that the difference, that your TCNT did not overflow here because you made it slow, count slower than the actual incoming pulse. And you know how fast the TCNT was counting, you can compute the time. This is using pulling because I'm here stuck waiting for a flag to rise. You can choose to do something else. Enable the timer and don't keep waiting for it. It will take you to an interrupt service routine. Over there, go capture the value. I'll share, and this is some key C code. Yeah, you can go through. I'll go through my code. These are all examples from the book. Here another, write a program to measure the pulse width of a signal connected to port T0, input capture 0. The A clock is to 24 megahertz. Well, here, nobody gave you other constraints, and they didn't tell you how long is the pulse width going to be. So in this case, you need to count for overflows. It may happen because the time between the incoming signal on the HCS12 on port T0, the input capture 0, the signal, you don't know the pulse width, so a rising edge and a falling edge. You don't know how the pulse width is it going to be in terms of microseconds, milliseconds, seconds? You don't know. So you need, since the TCNT is the base, you need to keep track of how many times it overflows. Here in this example, the solution suggested is to use a 32 prescaler, slow down the TCNT of 32 times. Yani it will not increment every 1/24 megahertz. It will increment every this amount of time times 64, which is some math, 1/24 megahertz times 64. It will count every 2.6 microseconds, 2.66666 microseconds. صح؟ طيب. And it will overflow after, equals 2.666 microseconds. طيب, overflow after 65,536 counts. صح؟ after this times this. صح؟ 2.666 times 65,536 counts, and this is 174.7 milliseconds. 174.7 milliseconds. Okay, so you can do this configuration. We set the speed. We enable the timer overflow interrupt. Okay, and inside it, the timer overflow interrupt. I think I did some example last time, on the timer overflow here, and here, inside this interrupt, here, call something called count ++. عرفها globally. Okay, the prescaler, instead of being I don't know what was the prescaler, but you can configure it. It was 1. You can use a prescaler, make it count slower, and here every time you count a counter, call it overflow counter. And the way to count the time or compute the time, you have the overflow counter that counts inside every interrupt. Capture the value of the timer channel 0 using this way. Here, you capture the timer edge 1 here, capture edge 2 here. Then you will have all these variables. Your pulse width will be like this. If edge 2 was larger than edge 1, the pulse width will be the number of the number of times you overflow times 2 to the 16 اللي هي 65,536 plus the difference between H2 minus يعني H2 minus H1 يعني larger ناقص smaller. إذا H2 أقل you remove one from the count يكون لأنه it didn't complete a full count plus the difference. Okay, and this is a flow chart how to do it. And this is the code how to do it. And I have a code, a running code that we'll do in a class demo. Let's finish the output compare and we do both together. Yeah, we still have half an hour. We can finish this and do two demos. Any questions on the input capture? Is it clear?
Yes, Doctor, clear.
Output compare functions. You can configure any of the 8 channels we mentioned at the beginning here in the timer module. Any of these can also be configured using the TIOS as output compare. Using the TIOS register, this one, to work in the output compare mode. What does output compare mode? Output compare mode, instead of latching the TC and T counter, instead, in the input capture, the TC and T counter is latched to the timer capture register 0 مثلا, if you're using channel 0. Input capture 0, it will be latched to here. In the output compare 0, this says you go write a value in the timer compare register 0, you write it. You write value. When the TC and T becomes equal to the value you wrote in the timer compare register, you can generate an event on channel 0 pin, lower port T0 in this case. And this event could be a rising edge, a falling edge, or a toggle. We'll see. And you're outputting something. This is the concept of output compare. The value of the TC&T is running in the background. You wrote a value in a register called TC, depending on the channel number. When the TC&T is gonna keep running. When it becomes equal to this value, a compare will happen, and the result will be, oh yeah, they match. A match will happen. This will generate an event on a pin. Okay. We'll talk about forced. These are the logic that's supporting it. Okay. So to generate an event after a certain amount of time that you want, I want to create a rising edge after 10 milliseconds. Okay. I make the TC&T counter increment on every 1 millisecond. Then I copy its value, add to it 10, store it in the TC0 مثلا. This value is مثلا was 100. When it becomes, it will count 100, 101, 102, 103, and when it becomes 110, it will be equal to the TC0 match. Then a compare function or a trigger will be generated on the pin, a rising, falling, or flip. Okay. What kind of trigger we want to do, or what kind of event we want to generate on when a compare happens? We use 2 registers called TCTL1 or TCTL2 to use this 2 bits per channel. The first 2 bits for channel 0, 0, 0, no action, nothing will happen. 0 1 التقل يعني if the pin had a 0 previously, it will toggle, generate a 1. If it had a 1, it will toggle and generate a go low. Or it can clear the pin signal. يعني if it can clear it, if it was high, it will go low and stay low. Or it can set it. يعني if it was low, it will go high. If it was high, it stay high. A toggle will reverse it. And 2 bits per channel. So we have 16 bits for the 8 channels. We can use this output compare method to generate waveforms. يعني the input capture, we were able to detect waveforms, measure timing between events, between rising edges, falling edges, both. The output compare is the opposite. We can generate a waveform with specific timings that we choose. طيب, if we were asked to do this example, generate an active high 1 kilohertz digital waveform with a 30% duty cycle on port T0 pin. Use pulling method, يعني بتوج interrupt pulling, يعني keep waiting for the flag to check the sequence. I'm going to do this with interrupts. Here they're doing it without interrupts. ماشي? Check the success of output compare operation. Frequency is 24 megahertz of the E clock. طيب تمام. Here, if an active high 1 kilohertz with 30% duty cycle, shown here, the logic flow is that you want to go up for some amount of time, counts high, then you go down, counts low, then high, then low, and so on. Now, if you set the prescaler of the TCNT to 8, which means what? It means that the frequency of the E clock equals 24 megahertz. Then the time of the E clock equals 1 over this. This equaled what? We wrote it down, صح? It was, what was it?
0.04 microseconds.
0.04?
Yes, هيك حسبناها قبل شوي.
Microsecond. طيب. If we use 8 prescaler, then the time for each increment of what? Of the TCNT timer will be this time 0.04 microseconds times 8. صح? You're slowing it 8 times 0.04. يصير قديش؟ Let's compute it. يعني عشان specific, 1 divided by 24 meg times 8 equals 3.33. يعني this is times 10 to minus 7. يعني if we move it one step to the left, the decimal point, يعني 0.3333 microseconds, صح? Equals 0.33333 دوري microseconds, صح؟ هاي per each count. طيب, each count. If I'm asked to generate 1 kilohertz 1 kilohertz signal, okay, then the time here between a rising edge and this rising edge is what? If this was 1 kilohertz, the time is 1 over 1 kilohertz, 1 millisecond. So 1 millisecond divided by this, you will get how many counts you want, صح? So using our calculator, 1 millisecond, يعني 1000 microsecond, divided by 0.3333333 microseconds equals what? 3000, صح? 3000 counts. Then this needs 3000 counts. طيب, 3000 is for the 1 kilohertz. 30% duty cycle means 1/3 of the time low, high, and 2/3 low. So 1/3 of this is what? Or not one, 30% of the 3000 counts equals how many? 3000 times 0.3 equals 900 counts. Equals 900 counts. So you need to make the TCNT counter count for 900 times here. Counts. Then continue the 2100 counts low. Total is 3000. Total is 1 millisecond. This is 30% of the 1 millisecond. And this is the remaining. So this is what they did here. So you set your counter speed to 0.333 microsecond. We show how divide 1 millisecond over 0.333. You get 3000 counts, right? And 30% of them is 900. Okay, counts, and 2100 are low. Well, multiply 900 times 0.333. Every count is 0.33. That is 300 microseconds, and you'll get 700 microseconds low. Okay, now for the code. So now we got the math. Now we need to configure the TCNT clock prescaler. Then we need to say, go get the TCNT timer value, copy it to the TC0 plus 900. This will keep counting. The TCNT will keep counting 900 times. A match will happen after 300 milliseconds. You will have to be, before this, asking that when a compare happens, go low. And if you were high, or if you were low, you can ask it to go high the first time and then wait 900 times, counts to then go low. When you go low, you get notified. You say next time we go high. You count 2100 counts. You go high. When you go high, you say next time I want to go low. Count 900 times and say next time I'm going to go low. Okay. Count 2100 times and say next time I'm going to go high, and so on forever. Your code has to keep doing that. This is output compare, guys. Many microcontrollers only have input capture and output compare. Many microcontrollers don't have PWM modules. To do PWM, pulse width modulation, they do it using their output compare functionality. This is a headache that you need. Your code has to keep going with the signal. It is the event happened. Okay, next time we go high. The event happened. Oh, next time we go low. Okay, when we go high, we say 300 counts. When we go, we say 2000 times, and so on. So it's like as you were moving with the signal. Okay, we write this code with interrupts. Here, he's asking us to do it using pulling method, and here is it. Here's a flow chart for it to do it with, and this is assembly code, and this is C code to do it with. This is C code to do it with using the pulling method. No interrupts are used here. He said, I'm going to count high 900 times, count low 2100 times, set the registers to enable the TCNT with a fast time clear, disable the TCNT interrupt. He doesn't want to do interrupts, set the prescaler to 8, enable auto compare 5 function. Well, here it was, is it 5? 0. هذا غلط, 0. So anyways, you need, if you want to, this will output it on channel 5. You know why channel 5? And channel 5 on our board is connected to the speaker, the buzzer. the buzzer, to generate sound. Anyways, you can do channel 0, TIOS, instead of writing, it's ORing it with all zeros except the 5th bit, the 5th channel with 1. You can replace it with 0. And it's telling it here that in the control, the action is to pull high, clear the flag for the first. He's following the flow chart, and TCNT value is plus 10 will be the TC5. 10 counts. Yani after 10 counts, go high. And he's one start low, 10 counts, go high. Then afterwards, he keeps waiting for the flag until the flag is raised. Yani the time elapsed. Okay. Then he's saying next time start toggling. Toggling, and the value in the TC5 is the value plus the high counts, yani 900 times. Okay. Start a new outcome operation 900 times, low 0, enable OC 0. By the way, I review this code in the slides sometimes, and we find some problems in it. Anyways, enable OC5 interrupt locally. Why? He said without interrupts. Huh? Oh, he has an interrupt here. And if you're in the high, your timer value is the high count, and next time you go here in the else, your timer value is the low count, and the high count is always 900 and the low count is 2001. Let's do our own example. More examples. More. See, port 5 is connected on our board, the Dragon 12 JR, to the buzzer on the board. Okay, we have time to go through, to generate, to run to, let's do some demo. I'm not gonna write it from scratch. I'm gonna use previous old code that I have. ماشي. What do I do? Let me copy them. Input capture, all written in the past, output compare, copy them. Let me put them in the class demos. Here. Let me create class demo 14 folder. Class demo 14. Let's do it. 14 will be input capture to measure pulse width. So let me copy the code and run code warrior. I'll run one of them. I'll run the output compare, but here I'll just build the project. And this is code that I wrote more than 10 years ago. So let's start this, create project, store it in class demo. We just did 14, save, next. Oops, not this one. In this code, what I had, and here it is, this is the November 3rd, 2010, a long time. For sure you can improve on it. And it's done in a way, it was done I did it inside the class. And I told you the reason. Over there, I had 4 credit hours, not 3. I had much more time. Here, I defined the PLL, CI, to send the pulse width to the hyperterminal. Here are the overflow, edge 1, edge 2, and difference, and some characters to send the numbers. Interrupt 16, is the interrupt that you will get into here every time the TCNT will overflow. Every time I get here, I check for a software flag that I do if true, because I don't want to the first time to start counting, and I don't want to overflow before getting the first rising edge. So this is just like an enable. Okay, when I get here, I clear the timer overflow flag and increment my overflow counter. Interrupt 9 handler. This interrupt serves routine for the rising or falling edge interrupt on input capture 1 channel. If for the first time the flag is not equal 0, the flag initially, it's a logic that you can write. Initially, I initialize the flag at 0. So the first time the S interrupt happens, I don't execute this code. Okay, I don't want to execute this code. If it's not 0, the flag is 6. The flag is 6, so I'll go here, right, and execute this one. Edge 2, flag is 0. The first time is 0. So the first time I get here, I get the timer capture register 1, store it in edge 1. And here I set the input capture 1 to latch next time on the falling edge. The first time in the initialization here in the main, I ask it, I enable the TCNT timer with fast flag clear. I set the prescaler for the TCNT to 32. Set the channel to be input capture in the TIOS, latch the counter on a rising edge. These are initial settings. Clear the input capture 1 flag for the first time, then enable it. Enable the interrupt, enable interrupts globally. The first time you get in the interrupt, this interrupt handler 9, you will come into here, latch the value on the rising edge. Next time, here I made the flag to become a 1. So next time I'll get here and latch on the falling edge. Okay. In between, the overflow counter will be counting how many times I overflow. And after capturing the falling edge, I compute the pulse width. The pulse width in this case will be the overflow, how many times I overflow. Okay, and this could be a big number, so I casted this to long 32-bit times 65,536 unsigned. 2 to the 16 or 0xFFFF. Okay, plus the difference. Difference is computed here, H2 minus H1. Then I compute. I had a big number of 10 digits. I assumed I have 10 digits. I divided it into 10 digits. By taking the remainder of the dividing by 10, then taking the other digit 9, 8 until digit 1, and inside my main loop, I just send it to the hyperterminal. Okay, and it ends. It only measures one because here I disabled interrupts when I'm done. Here in the interrupt service routine, I disabled everything when I'm done. So it only measures it once. I'll share this with you. And let me do the last one before releasing you. And because this one, the output compare. Let me do the output compare. Output compare. Here we'll generate the 1 kilohertz with interrupts. We went over it, so this one is with interrupts. The same math we just did. 3,000 counts and everything. But I'm going to use the hyperterminal to be able to change the pulse width. So let me create a new project. Class demo 15. And here is the same as what we saw in the slides, but I use interrupts. And I'm using 2 output channels, output compare channels, to generate the 1 kilohertz that it was asked for on 2 channels, channel 5 to see it, to hear it on the speaker, and we can connect another channel, and you put an LED, and when you change the pulse width, you change the intensity of the light. So I used output compare 3, interrupt 11, and output compare 5, interrupt 13. I did the exact same thing, but using 2 different channels. The high count is 900, the low count is 2001. The math is done with that, what we just did. So in my main program, I did the PLL, initialize the serial communication. Then here I've recommended enable the TCNT counter with fast flag clear, use 8 pre-scaler. Then set output compare 5 and output compare 3. Here the speaker is connected, and here I can connect an external LED. Then I'm saying output a high voltage on a successful comparison for channel 5 and for channel 3 in these 2 registers. Reset all flags. Go high after 5 counts. And this is for the first time. Okay. Then while the flag ended with 0x28, يعني في 11 صح؟ اللي هم 3 and 5 are still zeros. I keep stuck here. When they become ones, I ask them to toggle. The toggle. Then, okay, first time. Then I say that the time the compare register is the TCNT value plus the high count for 3 and for 5, both of them. Okay, and the flag, the high-low flag, and now the high-low flag, we start with 0 for both 3 and 5 channels. Enable the interrupts for both. Okay. Inside the main loop, I'm only receiving 3 digits that I compare and create a 3-digit number to use to change the value of the high count. The high count will be the reading I'm going to read through the serial port. The low count is 3,000 counts minus the high count to relax how much we're going to stay low. And the high count, low count here. First, we started with high count 0. So the first time the compare register will be the TCNT value plus the low counts. Okay. The low counts in this case are the 2001. And the other time it will be the high count in 900, sorry. And this is something we're going to be overwriting. Okay. Let me run this on my microcontroller and see what we have. Okay, 2 or 3 minutes, and we're going to add COM3 programming. Okay, I'm going to close this, turn on to run mode, leave, and this is a timer port T. Do you hear something?
Yes.
Let me close this. Let me run. Where did we use the hyperterminal? Here, 11. Oh, okay, I'm going to run the hyperterminal to change this. COM3, 9600, hardware, none. Okay. So it was 000, sorry, 900. Now it's 3 zeros. See the sound changed, the frequency?
Yes.
See, I'm changing how much high I'm staying. Of course, I can show you the oscilloscope. You're going to see a pulse width changing. I can add the 4th digit. This is the concept. If you put an LED, you'll see it changing its brightness. If you put a motor, this will be, we're varying the pulse width. And you're going to be changing. This is pulse width modulation, but using the output compare. But since the time we're staying low is 1 millisecond, for motors, this is not enough. And 2, anything over 2 is reasonable, but 1 maybe is, or in micros, is not going to be enough.
هذول القيم اللي انت بتدخلهم هم اللي بيعملهم كومباريزون مع ال TCNT value.
شوف القيم اللي بدخلهم هذول هم.
Yes.
Let me stop this because it's noisy. The values I'm entering here, Mustafa, are where is the project? Where is the project? It was demo 14. The values I'm entering here are these, Mustafa. Initially, to do the 1 kilohertz with 30% duty cycle, we had initially, initially the high count, how many counts I'm going to say high, was 900. Where was it? Where was it? High count to low count here. Where did I write it? Is it what is this?
فوق دكتور اتوقع فوق اول شيء.
لا لا هاي input capture. I'm sorry. I think we need this other one. No, 14, 15. 15 صح؟ في 15 yeah. Yeah. هذول مصطفى. I'm changing this number. The high count 900. The 900. This one. I'm changing this number in this example. وين هذاك الexample? I'm changing this number, Mustafa.
تمام دكتور.
Number. Okay, that's what we computed to be 900 initially at 30% duty cycle, but I'm changing it. Now, in my code, I'm reading through the serial port 3 digits, 1, 2, 3. The first digit I multiply, I remove minus hex 30, yani to bring it, because it's a ASCII code, times 100, plus the second digit times 10, plus the third digit times 1. So I get a digit of a number of 3 digits from 000 to 999. This is the reading that I give it to the high count. The low count is going to be the 3000 counts minus the high counts. So I kept the period. I kept the period at 1 kilohertz. Okay, the frequency. But I'm changing the pulse width. And this could be handy for you if you wanna, and you know how to start generating output compare. And if you want channel 1, you go get the number of interrupt for channel 1, and here you just update some of the registers, right? To do, and go revise all registers to include channel 1. Okay, guys, 6:17. I'm done here. If you have any question, you can stay. Thank you very much. See you.